Okay, our final topic of this chapter is wave function. As I already mentioned, the de Broglie hypothesis that a wave is associated, according to de Broglie, a wave is associated with a particle. Okay. Now, what is a wave function? A wave function is basically the variable quantity which characterizing the de Broglie wave. Is known as a wave function. Now, there are different properties of this wave function. So the first property is a wave function which is represented by this, let's say psi, is the generalized language used to describe atomic particle. So a particle is always represented by a wave functions. Okay, this is the particle which is represented by this wave function. So once we know this wave function, then we can get all the information about this particle. Like we can calculate its energy, its momentum, its speed, its acceleration, etc. So the wave function, secondly, the wave function which is basically a function of the three coordinates x, y, z as well as time. For a particle contain all the information about the particle. Like a particle is represented by a wave function, or we can say that a wave function is the generalized language which is used to describe a particle. So once we know the wave function, then we can calculate all the properties of the particle. I already mentioned here the energy, momentum, speed, acceleration, etc. and etc. So we can say that the wave function, which is a function of the three coordinates in time, for a particle contain all the information about the particle. So we can say that this wave function describes the distribution of the particle in space. Now, secondly, we can say that the wave function, this psi, is related to the probability distribution or the probability of finding the particle. In space. So this psi basically tell us the probability of finding the particle in space. If the probability, I can say that the particle is more likely to be found in region where psi is large. If psi is large, if the value of this psi is large, this implies that we have the maximum probability of the particle at that region. Maximum probability of finding the particle. If psi is small, then the probability of finding the particle in that region is small. Now, next we have another property of this wave function. If the particle possesses certain charge, if the particle possesses certain charge, then we can use the wave function for finding the charge density. At any point in space. Like if a particle has a certain charge, then we can use the concept of charge density, and the charge density can be calculated from this wave function at a particular space. So finally I can say that the wave function psi can be used to calculate the average position, not the exact position, but it's the average position, average velocity, and energy of a particle. So this was all about a wave function. So this is the end of this chapter, which is basically the quantum mechanics. In the next video I will move to the atomic physics, which so in the next video I will use atomic physics. I will discuss atomic physics. Thank you.